Chapter 12, World Climate and Climate Change. So if you look at the name of this chapter, there are two broad topics that we will cover. One is the world climate and the other one is climate change. When we say world climate, you must immediately think of the latitudes, those horizontal imaginary lines you see on a world map. The reason I asked you to look at the latitude is that as we go away from the equator towards the poles, the temperature drops. And the reason is simply because the solar radiation falls more at the center of the earth, which is the equator. And as we go towards the poles, the sun rays fall in a slanting manner, which gives lesser heat. Now, because of this differential heating pattern, different places on earth have different climatic conditions. And these different climatic conditions have been grouped in the following manner, about which we will read as we go ahead. And that's what we mean when we say world climate. And the second topic is climate change. After knowing the climatic condition of various places on earth, we will get to know about the climate change. So climate change is very closely associated with global warming, and it poses a fundamental threat to the land, ocean, species and people's livelihood. So these are the two main topics that we are going to read in this chapter, and at the end, it will give us a broader understanding of how climate has a direct impact on the social, economic and cultural aspects of human life. Alright, so climate has been broadly classified into three categories: empirical, genetic and applied. Now, what do we mean by that? Before we understand these three categories, I want to quickly say this. Let's assume you need to find out how much the climate of a particular place has changed over time. How do you do that? Well, you need a daily, monthly or yearly record of weather and climate data, right? If you have this data set, you can pretty much find out the average temperature, or you can find out the standard deviation as to how much the temperature has changed over time, right? So basically a climate and a weather record have to be maintained. One good way of collecting such a data is you go to Google and search for the temperature of any place. You find daily weather readings. If you copy all these readings in an Excel sheet, that becomes a data set. So like this, every region's meteorological department collects and maintains a data set. Alright, so far I hope it's clear. Now let's get back to the three broad categories in which the climate has been classified. The first one is empirical classification. The meaning of the word empirical is factual, real or verified and observed data. So empirical classification means that the climate has been classified based on observed data. Just go back to the example that I gave moments back. You go to Google and search for the temperature of a particular place. If you copy all the daily temperature readings and put it in an Excel sheet, that becomes an empirical classification of climate. The second one is genetic classification. So when you look at the word genetic, you must relate it to the word genes, because when we study genes, we try to find the origin of whatever that we are looking for. So genetic classification of climate means classifying the climate according to their causes or origin. Now if you remember, I said climate is not same everywhere, and it is due to the differential heating pattern of places on earth. Now this differential heating pattern is due to the incoming solar radiation on earth, which is uneven. Not all places on earth receive equal amount of sun rays. And you also know that because of differential heating pattern, the air becomes warm as well as cool. Then it also causes high and low pressure belts in various places. So when we have genetic classification of climate, it means classifying the climate according to its causes and origin. So here the causes of climate change are due to the elements like solar radiation, air mass, pressure system, etc. So genetic classification of climate is based on its origin or cause. And the third category is applied classification. Now if you look at the word applied, it means to apply for a specific purpose. So applied classification of climate focuses on the needs of economic and social life. I'll give you a quick example. Suppose we do classification of climate based on characteristics like the thermal heat, humidity condition, the nature and speed of the wind, and the depth of snow. So this kind of classification can help us in making the economic estimation. For example, housing construction, large-scale agricultural activity, energy generation, then damage to public property due to snow and rain. These are few examples that require economic estimation. In order to conduct an economic estimation of these activities, we need to classify climate so that necessary steps can be taken and resources can be allocated. Because you see, indirectly, the climate influences a country's economy and its stability. That's why the applied classification of climate is aimed towards taking concrete decision related to the needs of economic and social life. Now let's go to the first topic of this chapter, Köppen's scheme of classification of climate. So this person, Vladimir Köppen, who was basically a Russian-German climatologist, he classified the climate of the world by finding a close relationship between the vegetation and the climate of a particular region. His aim was to make a chart with formulas and notations that would define the climatic boundaries in such a way that it showed close similarity with the existing vegetation. If I have to say it in a simple way, basically he looked at the trees and plants of a particular region and then he figured out the relationship between the vegetation and the climate of that region. By finding a close relationship between these two, he created a chart which categorizes different climates in groups along with their characteristic traits. For categorizing climates in groups, he used capital and small letters. I'll show you the table. On the left column, you can see how the capital letters A, B, C, D, E, H have been used to denote climatic groups. Then on the right column, you can see the respective characteristics. I want you to pause the video and quickly take a look at this table. And don't worry, I'll explain each of these groups in detail. Now have a look at this table. The left column is exactly the same, but there are two new columns which denote the type and the letter codes. For example, Group A is tropical humid climate. Under this, there are three subdivisions or types. They are tropical wet, tropical monsoon, and tropical wet and dry. And then you have the letter code, which represents the subdivision of climates. And on the extreme right column, we have the characteristics of the respective climatic groups. Now, I have made a separate playlist consisting of short videos on these individual climatic groups. These short videos will come handy, and I have explained almost everything about these individual climatic groups in these videos. I'll put the link of the playlist in the description, or you could simply search for World Climate Köppen Classification and you will find the playlist that I'm talking about. So don't forget to check out the playlist. It's an important topic of this chapter. So go to the link and have a look at it. Let's go to the next topic, climate change. Before we go much deeper into this topic, I would like to first tell you the difference between weather and climate. The main difference between the two is that weather changes on day-to-day basis and climate does not change for a longer period of time. So the key element here is the measure of time. Weather is recorded and observed over a short period of time, and climate is how the overall atmosphere behaves over a long period of time. Now that you know the difference between weather and climate, here it says the type of climate we experience now might be prevailing over the last 10,000 years with minor fluctuations. I think you can easily understand this line because practically if you see in the last 10,000 years, there hasn't been any major physiographical or geological changes. When we say 10,000 years ago, we are somewhat referring to 8,000 to 7,000 BCE. During this time, agriculture was widely practiced. Of course, the human population was only few millions. They mostly lived in caves, and all their food came from wild plants and animals. Then later humans started settling down, and in these settlements they domesticated some of those animals and started off with agriculture to meet their food demands. Now you can easily imagine that 10,000 years ago, humans chose a particular place as their settlement. Then obviously their primary consideration was regarding climate and weather. They must have noticed the weather and climatic pattern, which definitely formed the basis of their settlement. And those settlements grew over time into larger cities and towns. You see, broadly speaking, the climate did not change except for few minor fluctuations. Because if there was any major climatic fluctuation, then early humans would have left those places. And today, the climate is slightly different, and these minor fluctuations are due to burning of fossil fuels. In other words, we inconsiderably pollute the environment and generate more waste. So yeah, this line absolutely makes sense regarding climate. One more thing that you will hear a lot these days is about climate change. And climate change is real. In fact, the objective of 2015 Paris Agreement on climate change is to limit the overall temperature of the Earth. Now, climate change is a natural and continuous process. But then in recent times, it has been more because of human activities. Otherwise, since the beginning of time, the change in climate is a natural and continuous process. And there's a lot of evidence that proves this theory. If you go to the higher latitude areas, there you will find steep landform, and mostly it's due to the melting and movement of glaciers. When temperature changed with time, naturally the glacier started moving. When glacier melts, it begins melting from lower end, and that makes the glacier move towards one direction, which eventually creates friction for the land below the glacier to move accordingly. That's how steep landforms were formed. And if you look at the sediment deposits in glacial lakes, it gives us the evidence of warm and cold periods, because glacial lakes are formed due to melting of glaciers. So basically a glacier is an ice sheet that lies on a bedrock. When glacier melts, it creates a friction on the underlying bedrock. The bedrock starts to erode into tiny sediments that later on gets deposited in glacial lakes. So you see, it's a natural mechanism that works when temperature is cool and eventually gets warm. And finally, if you look at the rings in a tree, it tells us a lot about wet and dry periods. I mean, there's a scientific method of looking at these tree rings, and that can tell you the exact year when they were formed. And by looking at the size of the ring, we can figure out whether it was cold year or warm year. During cold years, the ring is bigger, and during hot years, the ring is comparatively smaller. If you want to know an example of climate change, which is related to our country, India, so here they have very nicely mentioned about the Rajasthan desert. Around 10,000 years ago, that is around 8000 BCE, Rajasthan experienced wet and cool climate. That means once upon a time, it rained heavily in Rajasthan desert. And it was all so cool. But then during night time, anyhow deserts are cold, right? So what is interesting is knowing that it rained heavily once upon a time in the desert of Rajasthan. Now, if you have a general curiosity about how did the sand in the desert appear, I mean, from where it came, how did it all happen, then you need to understand that there can be two possible reasons. Either the desert appeared due to movement of Earth's huge land plates. I'm talking about the movement of Earth's lithosphere. Because of that, massive geological changes take place, so that could be one possible reason. Or the second reason could be maybe this sand in the desert came or appeared because of the rivers or streams that must have eroded rocks into tiny sediments, or the river might have carried the sediments from one place to another. So these are the two possible reasons. And now when we read here that the Rajasthan desert experienced wet and cool climate around 10,000 years ago, then the possible reason is maybe at that time, massive portion of the Rajasthan desert must have been under a river. Well, if that's the case, then the desert we see today, once upon a time was covered with green trees. With this example, we understand that since the beginning of time, the change in climate is a natural and continuous process. And the type of climate we experience now might be prevailing over the last 10,000 years with minor fluctuations. About this little paragraph, I'll make a separate video on Earth's geological timescale. In that, I'll explain what the Earth went through at different period of time. And it will give you a broad understanding about the Earth's history with respect to time and relationships of events. Alright, let's go to the next topic, climate in the recent past. So recent past means 100 to 200 years from today. I mean, Industrial Revolution took place in 19th century around 1880. Since then, the Earth's temperature readings have risen continuously. I mean, no doubt that Industrial Revolution made life easier. But then we also need to look at the cost. If you see, Industrial Revolution was dependent on three key natural resources, that is iron, coal and water. Now iron was used for machinery, water was used as a source of power and also as a mode of transportation, and then coal was used to power steam engines. You see, coal is a fossil fuel. Steam engines and other kinds of machines of Industrial Revolution used coal as a fuel. Now burning vast quantities of coal produced enormous amount of smoke, and that led to air pollution. And it even continues today. Or maybe I'll go on to say that it is much more today. So in a nutshell, burning of fossil fuels is one major contributor towards global warming and climate change. Have a look at this graph. You can see how the global surface temperature has increased since the Industrial Revolution. On y-axis, you see the rise in temperature in Celsius. 1 degree rise in the surface temperature of the Earth is actually a matter of concern, because even 1 degree rise in temperature is enough to warm all the ocean, land and the atmosphere. So that was a brief synopsis on climate change since the Industrial Revolution. However, I want you to pause the video or maybe look at your textbook and go through these dates and their respective events that were recorded. So here it says the 1990s recorded the warmest temperature of the century, and some of the worst floods around the world took place during that time. Then one of the worst drought that occurred during 1960s and 70s was in Sahel region. I'll show you where Sahel is. This region over here. Sahara Desert is here, the northern part of Africa. Countries like Algeria, Djibouti, Egypt, Libya, Morocco, Somalia, Sudan and Tunisia are part of Sahara Desert. And below that we have Mauritania, Mali, Niger, Chad and Sudan, which are sub-Saharan countries, meaning they are not 100% part of Sahara Desert. So that makes this region Sahel as a transition zone between an arid and semi-arid region. So arid means completely dry region, which is a desert, and semi-arid means there is a little bit of vegetation due to very low rainfall. Then during the 1930s, there was a severe drought in southwestern Great Plains of United States. So when we say Great Plains of United States, it is this region. If you look at this map of USA, this red portion is the region of Great Plains that witnessed severe drought during 1930s. So these are the states that are part of this region. Just have a look at it. So obviously if there was a drought, then it must have affected the agricultural business. Because when we say Great Plains, that means this region has to be highly suitable for agriculture. And because of the 1930s drought, there was a massive crop failure. Then agriculture business went down, people migrated. So I think it is a good example of how the changing climate affects humans both socially and economically. Even Europe witnessed warm, wet, cold and dry periods in the 10th and 11th centuries. So Ice Age is an era when huge parts of the planet Earth was covered with glaciers. And I don't have to tell you where the Ice Age was super active. You know, you can easily figure out that is in the higher latitude areas, Ice Age was extreme. Because we have read numerous times that as we go away from the equator, temperature drops. So Ice Age naturally had to be in the higher latitude areas. That's why when you go to Antarctica or Arctic region, these are the only places where you will find massive amount of glaciers all throughout the year. However, there was one point in time when massive sheets of ice from the Arctic region and Antarctica covered large parts of Europe, North America and South America, and also some areas in Asia. And that's why today also these places at times get super cold. So anyways, the whole point is that today we are no longer in Ice Age. Today we are in interglacial period or Holocene period. Ice Age lasted till 11,700 years ago. Since then the temperature has slowly gone up, and after Industrial Revolution it's increasing. I'll talk about all the geological time scale in a separate video. So there I'll explain in detail how the planet Earth went through different phases, what kind of temperature existed in those phases, and more importantly, how did we all evolve into what we are today. So yeah, I'll cover all that in a separate video. Anyways, that is all there is to read in this topic. Pause the video and read it once again and vaguely remember the dates. Now let's get to know about the causes of climate change. I'll quickly summarize this entire topic. Basically, there are 4 factors for climate change. So here it's clearly written that it is grouped into astronomical and terrestrial causes. Now astronomical means relating to astronomy, planetary heavenly factors, which is far beyond anybody's control and it is outside the Earth. I mean, Earth is smaller in front of astronomical factors. And terrestrial means something which is related to the Earth, things that happen within the atmosphere of the Earth. So basically the factors for climate change has been broadly categorized under astronomical and terrestrial causes. Alright, let's now understand those 4 factors. The first one is sunspots. Now sunspots are these dark spots that appear on the surface of the sun. I know, right? It's kind of crazy to even think of it that way because we have never looked into the sun directly, and we all have seen spots on moon. I'm sure it's highly unlikely that you have ever noticed spots on the surface of the sun. So anyways, there are some spots that exist on the sun, and these spots have low surface temperature. It's a temporary cool and dark region. Some of these sunspots are many times bigger than the Earth, and when I say these sunspots are dark and cool, what I mean is that the temperature of these dark spots is lesser than the rest of the surface of the sun. For example, if the temperature of the sun is 6000 Kelvin, then the temperature of these sunspots are 3700 Kelvin. So you see, it's a bit cooler than the rest of the solar surface. Anyways, the theory goes like this. When the number of sunspots increases, cooler and wetter weather and greater storminess occur. Because moments back I told you, some of these sunspots are much bigger than the size of the Earth. Just think about it. If the position of one of the sunspots is such that it is in direct conjunction with the Earth, then obviously the amount of incoming solar radiation on Earth will be affected, and that can cause cool and wet weather. Similarly, a decrease in sunspot numbers is associated with warm and drier conditions. That means incoming solar radiation on Earth will be in excess. So this kind of theory falls under astronomical causes. The second factor for climate change is Milankovitch oscillation. Even this one falls under astronomical theory, because this factor is beyond anyone's control on Earth. No one can do anything about it. Anyways, this theory talks about the variation in Earth's orbital motion around the Sun. I think this shouldn't be hard to think about, because we know two facts about the Earth. One is that Earth rotates within its own axis, which determines our day and night. And the second one is that Earth revolves around the Sun, which makes the Earth experience different seasons. Now, we are interested in Earth's revolution. When Earth revolves around the Sun, Earth's orbit is not in a perfect circle. Actually, this is the picture that we have always seen. Here we see the Earth's orbital motion being a perfect circle. But that's not true. It is more of an elliptical shape where the Sun is nearer to one end of the ellipse. So this is the actual illustration of how the Earth revolves around the Sun. And one more thing that I want to specifically mention is that when the Earth travels one entire trip around the Sun, it does not return to the same starting point. There is deviation in the elliptical path after the Earth has completed one revolution around the Sun. And the reason behind this deviation is the result of gravitational attraction among other planets. You see, after all, every planet is revolving around the Sun. And then there are planets like Jupiter and Saturn. They are much bigger than Earth. Hence, their moving pattern around the Sun, in other words, their elliptical path has some effect on Earth's elliptical path. That's why the Earth, after completing its one revolution, never returns to the same starting point. And that is also the reason behind coordinating our calendar with the Earth's motion, which gives us leap year. If I have to sum up this concept in the most simplest manner, then just remember this. Earth is not exactly at the same spot in its orbit on your birthday every year. Alright, now you need to know is that the speed of the Earth in this elliptical orbit is maximum when it is closest to the Sun. And when it is far, the speed is minimum. So during the month of July, that is 4th July, the Earth is farthest from the Sun. This position of Earth is called aphelion, wherein we are 152.6 million kilometers away from the Sun. And on the other hand, on 3rd January, the Earth is nearest to the Sun, and this position is called perihelion. Here we are 147.5 million kilometers away from the Sun. Hence, we can say that the annual insolation, that is the incoming solar energy or sun rays, is more on 3rd January. And incoming solar energy is less, slightly less on 4th July of every year. Now obviously this is not a very big variation that you and I can feel. This is the theory part. In reality, we will not see the effect. I mean, on July 4th, you will not feel that the heat is less, or maybe 3rd January, you will not feel that the day is very warm. Because there are many factors in the atmosphere that hides the effect of insolation caused by aphelion and perihelion. But overall, the point is that even with the slightest change of the incoming solar radiation, there is an alteration in the amount of insolation received from the Sun, which in turn has some effect on the Earth's climate. The third factor is volcanism. So I want you to pause the video and guess under which category it falls. Is it astronomical or terrestrial? Alright, I'm guessing that your answer would be terrestrial. So volcano exists on the surface of the Earth, and terrestrial means something that is related to Earth. Now, we all must have seen a volcanic eruption. I mean, not in literal sense, but we must have watched it on TV or the internet. So volcanic eruption throws up lots of aerosols into the atmosphere. And these aerosols remain in the atmosphere for a long period of time and causes dull and grey sky. If the sky is not clear, then it will definitely block incoming solar radiation. So this question might come in your exam. How do volcanoes affect the climate? Then you should immediately think of volcanic eruption. When volcanoes erupt, they emit mixtures of gases and particles into the air, which are called aerosol. These aerosol includes carbon dioxide, sulfur dioxide, hydrochloric acid, hydrofluoric acid, and all of these mineral particles have serious effect on human health if exposed. In fact, they can also poison lakes and rivers, turning them into pools of burning acid that can dissolve all marine organisms. And I also said that these aerosols remain in the atmosphere for a long period of time, and then it blocks incoming solar radiation. Similarly, it also blocks the outgoing radiation. All of this becomes a defining factor for climate change. And the last factor is increase in the concentration of greenhouse gases in the atmosphere. Now, greenhouse gases are basically, I'll just put all the gases that falls under the greenhouse gas. Just pause the video and have a look at it. Now, these are a bunch of gases in the atmosphere that blocks the Earth's radiation from going out in the space. These greenhouse gas traps the heat within the Earth's atmosphere and makes the Earth warmer. Now, the interesting part to note is that the volume of other gases is constant, but the volume of carbon dioxide has been rising in the past few decades, mainly because of the burning of fossil fuels. Since the Industrial Revolution, that is from mid-18th century, the amount of carbon dioxide has increased. Machines on daily basis are using fossil fuels like diesel, petrol, and that's emitting more and more carbon in the atmosphere, which is increasing the overall carbon content. Now, if you're interested in watching a video on understanding the greenhouse gases and greenhouse effect, then I have a video on it as well. I'll put the link of that video in the description, just have a look at it. So if you read here, it says, it is an anthropogenic effect. Anthropogenic is related to environmental pollution that occurs due to human activity. So basically, it's a terrestrial cause. Alright, so with this, we have completed the 4 main factors that causes climate change. Actually, we are pretty much done with this chapter, except for this last topic, global warming. Even this topic includes matter that I've already covered in this chapter. Moments back, I told you about greenhouse gases. Then I also have a separate video on it. I have put the link in the description. Then I've also spoken about climate change, how it blocks the incoming solar radiation as well as outgoing Earth's radiation. But this thing over here, global warming, adversely affects the life supporting system. Now, this particular topic is something that I feel is very important, because if I have to rephrase this question, how does climate change affects humans and nations both socially and economically? So that will be the bottom line question if I have to rephrase it. So what I'm going to do is I will quickly explain this. I already have a recorded version of this particular topic that I have spoken in the past. I will simply put that clip and I want you to listen to it and you will get everything. So here we go. Let's get to know about climate change. Climate change is real. It's not a false story or a hoax. It's a reality. And by climate change, we mean that Earth's temperature is going up year by year. So since the Industrial Revolution, the temperature of Earth has gone up like anything. Industrial Revolution gave birth to machines, and machines are a very important aspect of our day-to-day life. It helps us a lot, but it consumes fossil fuel. And due to fossil fuel, greenhouse gas emission has increased. Now, what are these greenhouse gases? We are talking about carbon dioxide, methane, nitrous oxide, ozone, then sulfur dioxide. All these are called greenhouse gases. Now, the thing that these greenhouse gases do is that it blocks the Earth's temperature. Meaning, so the sun rays come inside the Earth's atmosphere, and that's what keeps us warm. If there is no sun rays, then we would have been frozen like anything. So sun rays are good. But the thing is that when the Earth's surface gets heated, the heat does not go out of the atmosphere. It gets trapped, and it is because of greenhouse gases. And over time, what happens is the temperature of the Earth increases. It's like a pressure cooker. If it is closed from all ends, the steam is inside, and if there is no way for the steam to go out, the temperature inside increases. So today, if you see, everyone's focus is on carbon dioxide. Everyone is trying to reduce carbon emission. And why? Because we modern humans have produced it and making it the largest greenhouse gas. And I've given you the reason, because of burning fossil fuels. And another thing that is happening is deforestation, that is cutting down forest cover. So I hope you know the role of trees, right? They take in the carbon dioxide and they throw out oxygen for us. So just think about it. We are increasing the carbon content and then we are also cutting down forest. It's a vicious cycle. Alright, so this was the initial story of climate change. Now last year during Paris Climate Deal, it was suggested that let's keep the temperature below 2 degrees Celsius. Because the theory was that if the Earth's temperature goes beyond 2 degrees Celsius in the coming future, then all the ice in North and South Pole will melt. And that's going to cause a big tragedy. So the plan is to keep the global average temperature low. Now people don't understand when scientists talk about 1 or 2 degree increase in temperature. People feel that it's alright, last summer it was 45, today it is 50, it's fine, it's not a big deal. But then if you take the entire temperature of the Earth and then you have to say that it is going to increase 1 or 2 degrees Celsius, it's a lot, because there are a lot of places, then there are a lot of species that cannot live beyond a certain temperature. We humans are exception because human beings stay in hot temperature like in the African desert, and then there are human beings who are staying in cold temperatures like in Siberia, Greenland, Iceland, all these kind of places. But then there are certain species that cannot live beyond a certain temperature. Now the crux of the matter is that if the Earth's temperature increases, then all the ice in North and South Pole will melt. Now what happens when ice melts? The sea level rises. It's very simple to understand. When a big portion of ice melts, then the water from that ice, it goes into the hydrological cycle, which is the ocean. And when ocean gets more and more water, it increases. And if the level increases, you know what can happen, right? It will cause floods, hurricanes at coastal region. So it will cause a massive geographical, social, and economical turmoil. So I want you to imagine this scenario. Suppose you're staying in a coastal area and there's a rise in sea level. So your coastal area is going to hit by flood. And if flood hits your area, you're going to go towards the plain area. You're going to move a little inside. One good example is Bangladesh. The region near Bangladesh and Sundarban area, it's a low-lying area. Now what is happening in Bangladesh is that the water level in Bay of Bengal is rising. And because of that, the water is entering into the coastal area. And people are relocating in the city area. They're going inside where it's upland. Now these people who have been affected because of flood, they don't have house, they don't have any job, they are destitutes. Now what is going to happen? It's going to increase the population of the city. So because of this internal migration, domestic migration, that is people shifting from one place to another, the domestic population of a particular place will increase. And that will put pressure on that particular place's resources. Human waste will increase, then there will be massive economic divide. So I hope you're understanding the trickle-down effect. So right now if you see, Arctic sea ice is shrinking and glaciers are melting. And if you want to know what's happening in Antarctica, a massive trillion-ton iceberg broke from Antarctica. Just look at the size of this iceberg. Now this iceberg is going to melt, and when it melts, the sea level will rise. And then most of the coastal region of United States, then Indian subcontinent, then Bangladesh, most of the low-lying areas will get affected. So this is the story behind climate change. Alright, I hope you now understand what is climate change, global warming, and how it affects all of us. I just want you to go through all these data. You just have to broadly go through it again. I've also pretty much covered it when I was talking about the global surface temperature. There's a picture also that I put up, so just go back and listen to it again. Otherwise, just pause the video and read it. Or you read it from your book and that's it. You don't have to remember everything. Just give it a quick glimpse. Alright, then with this, we have come to an end of this chapter. The question answers of this chapter is available on the website. I put the link in the description. Please have a look at it. And I also urge you to watch that playlist that I've mentioned in the beginning. That playlist contains short videos on various climatic groups. Those are very important topics of this chapter, so don't miss out on it. Please have a look at it. So almost everything is covered. And if you have any doubt or if you think any topic is left out, please put it in the comment section. I'll have a look at it. Alright then, I hope you found this video informative. Thanks for watching and I'll see you in the next one.